Hello everyone, welcome back to the another session in Principles of Programming Languages. Today we'll be going to start the fourth unit. Fourth unit is all about three concepts. The first concept is abstract data types or else abstract types. Second is encapsulation. The third is about monitors and the processing things, how we'll take one instruction into process, that the topic of fourth unit. So now today we'll be going to start with the first concept, which is introduction to data abstraction. So I believe strongly that you people know already about what is abstraction concerned to a particular language. So it is always true that the concept what you already know from one language, it may not be true for all the languages. As part of PPL is what? Studying about major programming languages. We'll study about principles of major programming languages. So data abstraction, coming to the concept of data abstraction, what you might have learned is, we'll hide some data and will not disclose the data to the third person or else client, you simply say. This is what we already have come across with the study from the previous semesters. So here, this topic will give you a knowledge that what is data abstraction concerned to the programming languages. It's not we'll deal about one programming language, it's all about the concern to the major programming languages. So what is data abstraction respective to the languages and how it is implemented? And here also we do have two kinds of data abstractions. One is an abstract type can be created by the user and an abstract data type can be also given by the programming compilers or programming interpreters, so concerned to the language. Now let's see about what is an abstraction and what kind of types of abstractions were there respective to the languages. Now let's understand about what is an abstraction. Abstraction is basically, it's a view of or representation of an entity. It's a view or representation of an entity that includes only the most significant attributes. So generally, if you take any kind of, let's say that I am taking a subprogram. Now I am writing function a comma b. For everybody, I don't want to disclose what this function performs because I am protecting my data or I am protecting my function from the third parties. If it is visible to everybody, maybe it is a function or maybe a class, maybe a method, it may be of anything. So how I can protect this from the client users or from third parties? I can hide the essential attributes not to display or not to visible by the other parties. This is what data abstraction. Data abstraction is what? It is a representation where the representation will have only the essential attributes. That's it. The implementation part of attributes will hide from the third person. Whoever the person I wanted to give access, for them I'll give. So how can I give? I'll use some access specifiers. This access specifiers will help me to reveal the data or to give access to the concerned person. Let's say there are three persons. The one is developer who is writing the functions. The other one is the user who wanted to use this one. The other one is a third party. Now, the person who was writing the program, this program he is writing for the sake to be used by the user. So user can use it for all the ways that he can see the implementation, that he can see the specification part and all he can access. But I wanted to restrict this user not to harm my data. Then what I'll do? I will hide this information by passing few access specifiers. And this is the concept of data abstraction. Mainly data abstraction is being supported with the languages where it supports object. The languages which are object based languages, because we'll create a reference to the class or we'll create an instance to the class where this whole method or whole things will get accessed through one reference, correct? So that reference is the one which can be visible to the user. Now, this is what the background thing about abstraction. Now, we'll see point by point. In the world of programming languages, abstraction is a weapon against the complexity of programming. The point is what? When you basically write a program, we'll write, let's say that I'm writing 100 lines of code. Yes, when I write 100 lines of code, now abstraction will hide some data, not too visible by some other party. That means I'm reducing the complexity of the program by providing data abstraction. Point to be noted here, when I write 100 lines of code, all these 100 lines of code is not visible to everybody. We'll hide the data, not too visible to somebody's. So we'll be reducing the data length, right? So that's what it is, a weapon against of complex programming. And its purpose is to simplify the programming process. It is an effective weapon because it allows programmers to focus on essential attributes while ignoring subordinate attributes. So these are what the things which specifies. This is what representation part. Okay, this is what representation or specification part. This is what implementation part. That's what basically, see, when you are using a computer thinks whatever it is designed, the language whatever it is using inside of it, we will not show them to all. Let's say that I am running my programs in C. Fine, I'm executing a C program structures and all. When I wanted to see how compiler instructions are being invented or being introduced in C, that will be basically hidden from the user. So that the same, will be giving only representation and specification part as visible, and this part will be hidden. Now, so there are two fundamental kinds of abstraction in contemporary programming languages. The one is about process abstraction, the other one is data abstraction. So wherever you have a term of abstraction, you just come to the one understanding that process will get initialized in the program or data will get initialized in the program, but the way how process is implemented will hide. The way data, how it will be implemented, that will hide. But what will show only specification, what process it is, the name of the process, the argument of the process, the data type of the process. These things will get visible to the user because they will have to use it. Unless and until I am not showing all these things, how can they use? So whichever is essential, that will show them, and which is not, it is useful to them, where I have a thought that they can hack it, that they can misuse it, then definitely we'll provide data abstraction and not to show to everybody. And coming to this data abstraction also, so basically data abstraction is what? When I wanted to use a data type, so data type as far as float point is considered, I'm just using it, right? If I give float A initialization in any of the programming language, the language which supports float as a data type, I'll not say about what the kind of A is. I just simply perform the operations related to floating point type on this A. That's it. So data abstraction is what? User is allowed to access what data type or performed on this A. That's it. Will not see how float is existed, what is the float implementation part, what I can add to float. These things are hidden to the user, right? So process abstraction, data abstraction, basic kinds of abstraction data types concerned to the all contemporary programming languages. Now let's see about process abstraction. So basically process abstraction has been taken from the first programming language. If you see about evaluation of programming languages or else genealogy of programming languages, there you might have seen about this term. This term is what? Plan calcul. This is what actually the next version of calculated and the first programming language. The reason why it was not that much familiar is this is the programming language which is not come to the implementation part, because the formulas what it uses, the syntaxes what it uses will not find it out on our keyboards. So that's the very reason. And the other reason is what? Basically, this language will use a large type of computations. Even the data types what we basically have, that data types will not support the data of this plan calcul. And that's the very reason this language is not coming to the domain of implementation part. Right. So though it is not coming to the implementation part, there are features what are rightly used in the languages. And one of the feature is abstraction. So the origin of abstraction is started from the plan calcul and the year is 1940. So from 1940s we were using abstraction in the language of this. Now all subprograms are process abstractions. That means every function you can say it is a process abstraction. Now I have an example here to show. Let's look at this example. Sort int list comma list length. Here sort integer is what? My function name. List length are what? The parameters. So what is data abstraction provided here? I am not disclosing what this function will perform. Though I am writing into the program, with the access specifier, I'll close the visibility of that implementation part and I'll give access to see about what is the function name, what are the parameters into it, and what is the size of this list. These kind of details will be giving accessible to the user to manipulate their own data. Fine. Now, so that's what here it is. We'll see. For example, when a program needs to sort an array of numeric data of some type, it usually uses a subprogram for sorting process. This is what the subprogram. At the point where the sorting process is required, now we'll use this kind of statement and it is placed in the program. This call is an abstraction of the actual sorting process whose algorithm is not specified. The call is independent of the algorithm implemented in the called subprogram. So this is the way how we will hide the essential attributes from the third parties. And so basically this evaluation has started from the COBOL. We'll see how the languages will support data abstraction. We started with the COBOL. How COBOL support data abstraction? That uses records. If you say even the records will display the label name, correct? We'll write only 01 and the employee name. There we'll hide the data of employee name in the form of record. So data abstraction is being provided, and there is a language of C. Even C will support data abstraction partially through the help of structures. We'll hide the data of structure and we'll create a member of the structure through which we will access the whole structure, right? So these are the programming languages which will uses different things of abstraction, and we'll see about even data abstraction. So this is about process abstraction. Now coming to data abstraction, let's look into the data type which is floating data type. Floating point types in high level languages employ a key concept in data abstraction. Why it is a key concept is the actual format of the floating point data value in a memory cell is hidden from the user. That's what, when you wanted to use a float of variable, we just apply it, we just use it. We don't see the implementation how float is existed. So this is what user defined data type. Fine. And now we'll see about the next thing, which is user defined abstract data type. Example is what? This. Look at this user defined data type. There I have defined some procedure, or you say it is a subprogram. Create stack, it creates and possibly initializes a stack object. Destroy stack will deallocate the memory which is allocated for stack, and empty stack will make empty after deleting all the elements of stack, or else if it is empty will push the elements inside of the stack, and pushing the elements and popping the elements, finding the top of the element. When you look at all these things, now this will be visible to the user, and the implementation part of each thing will be there in the program, but it will be hidden with the access specifier. So this is about data abstraction. Thank you all.